Okay, so thanks, Nance, brief for sharing about Pulsar functions, and connectors. Pulsar functions and connectors have made building event streaming apps much more simple. But we want to make Pulsar functions one more step. So we combined the Kubernetes and the Pulsar functions together to make a serverless framework that's natively on Kubernetes that running Pulsar functions and connectors, and we call it a function mesh. And the main purpose for function mesh are firstly integrating separate functions and connectors together to produce process data and accomplish a final processing goal with clearly defined stages. Secondly, to utilizing Kubernetes and native resources and scheduling capability. So function mesh is suited for common lightweighted streaming use cases such as ETL jobs, and it's not intended to be used as a full-powered streaming engine. So before digging into function mesh, I would like to talk about some pinpoint of Pulsar functions and why we built function mesh. So if you are familiar with the Pulsar functions worker, you may know that Pulsar functions do have a Kubernetes runtime. But with the Kubernetes runtime, function metadata is stored in Pulsar and the function running state is managed by Kubernetes. This may have an inconsistency between metadata and the running state. So like the stateful set running Pulsar functions can be deleted from Kubernetes while Pulsar does not being notified. Also, the existing implementation for storing function metadata may cause broker crash loops if the function metadata topics are not available. Certainly, function cannot be used across multiple Pulsar clusters, and the functions are tied to the specific Pulsar cluster. Also, currently, Kubernetes runtime is hard for users to implement certain features provided by Kubernetes, such as auto-scaling. And additionally, it is hard for users to manage multiple functions and bind them into a single job to achieve complexity processing goal. Without function mesh, user needs to do a lot of manual works and to organize and manage multiple functions to process events. So with this background, let's move on to function mesh. In function mesh, we have three core components, and which are Kubernetes operator, function runner, and mesh worker service. I will firstly go through the Kubernetes operator. In function mesh, we use operator SDK to define several customer resource definitions to allow user define functions, connectors, or mesh as a custom resources in Kubernetes. As the code block shown, so we define functions configuration as a function spec, and the function spec are implemented based on the Pulsar functions. So also we have the source and sink. Apart from them, and we also define a function mesh, or we call a mesh, which is a collection of functions and connectors connected to Pulsar by Pulsar topics to achieve a more powerful stream processing logics. So all functions and connectors in a mesh share the same life cycle. With the defined function mesh spec, all the functions and connectors are managed together, and which means They are started when a mesh is created and terminated when the mesh is destroyed. And here we have some external services like MySQL, MongoDB, Redis, or Kafka. With a solid arrow, it defines the data from or to the external services connected with Pulsar function, connected with Pulsar topics. With the outlined arrow, it defines the Pulsar topics to connect different functions and connectors. So here is what a mesh looks like. We assume a complex data processing flow is built with multiple Pulsar functions and IO connectors, and it's all connected by the Pulsar topics and defined as a one mesh. This diagram shows a typical user flow of function mesh. User firstly prepare the CRD of function mesh resources like a function kind YAML file or source kind YAML file or even a function mesh kind YAML file. Instead of using Pulsar admin or Pulsar control to create or manage functions, we can now use Kubi control to submit the prepared function mesh CRD manifest file directly to Kubernetes clusters. So in this diagram, within the Kubernetes cluster, the function mesh controller, which is in the mesh namespace, will watches the CRD accepted by the API server and creates related Kubernetes resources such as the stateful set to run the defined function or connector within the Pulsar namespace. So in this way, both function metadata and the function running state are directly stored and managed by Kubernetes, and this will avoid the inconsistency problem I mentioned before. Next, we will talk about function runner. Function runner invokes the functions and connectors logic when receiving events from input topics and produce the result to output topics. Currently, the runners are implemented using the Pulsar function runner. Now we have a self-contained function runner based on Pulsar function runtime. We built multiple individual function runner images based on Stream Native's Pulsar all image. And each runtime image contains the language-specific runtime and the related toolchains. We also published these runtime images like Java, Python, and Go with Pulsar 2.8.0, and we will keep update with Stream Native's Pulsar image. We also released a bunch of per Docker images for Pulsar IO connectors to Docker Hub, and each image is named as like Stream Native / Pulsar IO blah blah blah, like Stream Native Pulsar IO data generator. And we have released all Pulsar built-in connectors with some of the Stream Native managed connectors as a per Docker image. And you can check the list from Stream Native Hub. And here is the link of Stream Native Hub. So we have Kubernetes operator and function runner, and we can have the overall architecture of function mesh. So when a user prepared a CRD like function.yaml or function mesh.yaml, he can use the Kubi control to apply and create the function mesh CRD to the Kubernetes API server. And the controller of function mesh receives the submitted CRD from the API server. Then the controller processes the CRD and generates the corresponding Kubernetes resources, for instance, when the controller processes the function CRD, and it creates a stateful set to run the function. And each part of this function stateful set launches a runner to invoke the function logic. So you can see here the pod has a runner for the function source or sink. So with the native support of Kubernetes, function mesh can support automatically scaling of the number of pods based on Kubernetes HPA, which is a horizontal pod autoscaler. When users submit a CRD with max replicas, like this example shown, we set the max replicas to 8, and then the HPA controller will monitoring the related pod to determine if it needs to change the number of pod replicas. So currently we support monitoring based on the CPU usage. And lastly, we have one more thing, which is the Mesh Worker Service. Mesh Worker Service implemented with the Pulsar's Worker Service interface and packed as a NAR package, and you can use it as a plugin worker service along with the Pulsar brokers. It basically forwards the Pulsar admin's API request to Kubernetes cluster and directly operate on CRD. Which with the Mesh Worker Service, users do not need to change the way they manage functions with Pulsar's function worker, and can use the Pulsar admin with function mesh directly. Currently, because of some interface limitation, and the Mesh Worker Service only works with Pulsar 2.80 or even higher version, and it can manage function, sink, and source CRDs. The limitation of function of Mesh Worker Service is we cannot use Pulsar admin to manage mesh CRDs for now. And we also added some useful configs to allow users to customize the worker service. Like we can disable or enable the specific API endpoint, like a function endpoint or sink or source endpoint. We can even configure if we support user to upload their custom function or source sink jar package. And we can also define some Kubernetes resources like volume mount or volumes, and some other runtime configuration. Okay, and with the Mesh Worker Service, we also allow users to manage built-in connectors by defining a list of the metadata of supported connectors. It's basically the metadata looks like this code block, and user can just define the supported list, and we can use the Pulsar admin to get the available source or available sink as the built-in connectors. Here comes to the summary, which I will elaborate the key benefits of function mesh. So we built function mesh to ease the management of Pulsar functions when you run multiple instances of function together. And the function mesh utilizes the full power of Kubernetes scheduler, including development, scaling, and management. It also makes Pulsar function run natively in the cloud environment, which leads to great possibilities when more resources become available in the cloud. And lastly, function mesh enables Pulsar functions to work with different messaging systems and to integrate with existing tools in the cloud environment. This is because function mesh run Pulsar function independently from Pulsar cluster. And finally, I will talk about some future plans. And firstly, we want to improve the capability level of function mesh operator. And we also want to add more Pulsar functions feature to function mesh and extend the feature partly. And such as we want to add the stateful function to function mesh. And we want to support additional runtime based on self-contained function runtime, such as we want to add WebAssembly runtime to function mesh. And also, we want to develop better tools or front-end UI to manage and inspect function mesh with such better usage tools. And we also want to group individual functions together to improve latency and reduce cost. And lastly, we would like to have support advanced auto-scaling, which we will expose more metrics to each function and have advanced auto-scaling supported based on the extended metrics. So that's end of my share. And if you are interested in function mesh, you can come to our website, which is functionmesh.io. And for detailed docs about installation, usage, and development. So we also open source the function mesh on GitHub, which is the stream native / function mesh. And welcome to start, fork, or posting issues and pull requests. So if you want to try function mesh on your local machine, you can start with our one key installation script. It will start a kind, which is Kubernetes in Docker cluster on your local environment, and install function mesh to the kind cluster. Also, we have provided Helm charts to install function mesh to any existing Kubernetes cluster. Currently, it's not published to the chart repo, so you may have to clone the function mesh first and install it with Helm. So if you have any questions, please feel free to contact us on GitHub. And next, back to Nan, and he will give us a short demo with function mesh. And thanks.